Hi everyone, welcome back to course on CFD, Computational Fluid Dynamics. Uh, Let us start session 3, which is approaches and flow models which we come across in CFD. So let's go to the outline of the session. So we'll be discussing about what are the approaches, then what are the flow models which we come across, which includes control volume approach and infinitesimal element approach. So in fluid dynamics, basically there are two approaches. One is Lagrangian approach and other one is Eulerian approach. So this is based upon the motion of the particles, size of the particles, as well as the area of interest for studying the physics of the problem. So these two are basically two approaches wherein we study the flow behavior in two different scenarios. So let us see the first one, which is Lagrangian approach. So Lagrangian approach is basically an approach where we concentrate most probably on individual particle, mostly on individual particles or objects which are moving in the space and time. So here we will be following each particle, and based upon the behavior of each particle, we will be predicting what is the nature of the flow. For example, we can see that this particle is moving. So this is the domain of the flow, or this is completely a fluid, and this is a particle in the fluid. This is a particle in the fluid. So the behavior of complete flowing fluid will be now predicted based upon the particle movement. That means if particle is following a particular path, based upon the nature of that path, we will be predicting the velocity of the fluid and the direction of the fluid, net direction. For example, you can see the fluid is in the particle is moving in wavy form, so we will consider fluid to move in wave form. So Lagrangian approach basically will not consider whole region of the fluid, rather it considers only one single particle, and based upon the behavior of this particle, the whole fluid will be, or fluid behavior will be predicted. So the best example is, if we throw a thermocol ball into the water and we observe that thermocol ball, the path traced by thermocol ball will be used by me to predict the behavior of the flow. So this is the Lagrangian approach. Now let's see the Eulerian approach or Eulerian approach. So Eulerian approach uses a specific region. So unlike Lagrangian approach, where you are concentrating on one single point, rather Eulerian approaches considers a region for predicting the parameters. So it measures what is happening at a particular region or a particular space, and it measures the properties in this particular region. It measures the properties in this particular region to predict the fluid flow behavior. So the best example can be water flowing through tap. Water flowing through tap. So here we are not considering any particles. We are not considering any of the particles. Rather, we are considering it as a whole fluid flowing. So we can estimate velocity of the fluid by calculating the volume of the fluid which is being discharged. Divide the volume with the volume flow rate with the area, you get the velocity of the fluid. So Eulerian approach doesn't consider a specific particle. it considers a specific region of the complete flow. Okay, so let's move to next topic, that is models of the flow. So models of the flow. So before going to this model of the flow, let us understand what is the need for them actually. See, as we discussed, CFD relies purely on mathematical models. Then there is a need to define the physics or the physical region where we are going to apply the laws of fluid flow. That is conservation of mass, conservation of momentum, and conservation of energy. These physical laws will be applied to a specific region. Those regions where we are applying these physical laws, we call them as regions. We call them as models of the flow. So basically these are classified into two types. One is control volume and infinitesimal element model. So coming to control volume. So control volume model. So control volume is basically a region in the space with a specific volume. So you have a region in the space. So all the focusing will be done only in this fixed region, and the region will be evaluated for various properties. That is, what are the changes in velocity, what are the changes in pressure. So these kind of characteristics will be measured in the control volume. So basically control volume is nothing but a large volume or space where the physics is carried out, that phenomena is evaluated. So here you can see this control volume approach can be classified into two types. One is control volume fixed in space, other one is control volume moving with space. So you can see that. So here this is the control volume. Here the control volume, you can see it is moving from one point to other point. So control volume fixed in space, control volume moving in space. So you can see in the control volume fixed in space, the fluid particles are moving, whereas in the control volume moving with space, the whole control volume is moving along with the fluid. So next is infinitesimal element or infinitesimal fluid element. As you can see, this is the infinitesimal fluid element. What are the changes happening across this element? What are the changes are happening across this element will be evaluated. Basically, the name itself indicates that it is very small element. Why we considered this is this it helps in linearizing the problem. The size of the infinitesimal element is so small that across this element we consider properties to vary linearly. The properties can be assumed to vary linearly across this element, thereby reducing the complexity of the mathematical model. So other one is control volume moving in space. You can see how it is moving. So basically along with the fluid, even this particle will be moving. So this is a summary of today's session, that is Lagrangian approach. So we discussed about Lagrangian approach, we discussed about Eulerian approach, then we discussed about flow models, which includes control volume as well as infinitesimal element. Both we discussed along with the two different categories, that is control volume fixed in space and control volume moving with the space, and infinitesimal element fixed in space and infinitesimal element moving in the space. Thank you.